Hello everyone, welcome to Gomati's collection. இன்னைக்கு நம்ம பார்க்க போற டாபிக் என்னன்னா +1ல third unitல ஒரு important topic, that is using a free body diagram show that which it is easy to pull an object or push an object. ஒரு ஆப்ஜெக்ட புல் பண்றது, ஐ மீன் இழுக்கிறது ஈஸியா இல்ல புஷ் பண்றது தள்ளுறது ஈஸியா அப்படின்னு சொல்லிட்டு பார்க்க போறோம் using free body diagram. First we have taken the case that is pushing an object. Consider this is a block. ஒரு block tableல இருக்கு. இந்த blockை நம்ம புஷ் பண்ணும்போது அந்த ஆப்ஜெக்டோட ஃபோர்ஸ் எப்படி எக்ஸிபிட் ஆகுது, அதனால அந்த ஃப்ரிக்ஷனல் ஃபோர்ஸ் என்னவா இருக்கு, நார்மல் ஃபோர்ஸ் என்ன, கிராவிடேஷனல் ஃபோர்ஸ் என்ன, இதை வச்சு புஷிங் அன் ஆப்ஜெக்ட் இஸ் ஈஸி ஆர் புல்லிங் அன் ஆப்ஜெக்ட் இஸ் ஈஸின்னு சொல்லிட்டு 2 cases நம்ம வெரிஃபை பண்ண போறோம். திஸ் இஸ் த சிம்பிள் டாபிக், ஓகே, அண்ட் இட் இஸ் ஆல்சோ ஒன் ஆஃப் த இம்பார்ட்டன்ட் டாபிக். வைல் புஷிங் அன் ஆப்ஜெக்ட், இந்த பிளாக்கை நான் புஷ் பண்றேன், அப்போ normal force acting on the object, normal on force is acting on this object, which is equal to the gravitational force plus the total force acting on it. So free body diagram சொல்லும்போது upward always indicates as normal force and downwards indicates as gravitational force. The block is pushed, so some of the frictional force is acting. அந்த block நான் புஷ் பண்றேன் அப்படின்னா frictional force இருந்தாதான் we can able to change the position of the block from one point to another point. ஒரு பாயிண்ட்ல இருந்து அது இன்னொரு பாயிண்ட்டுக்கு நம்ம டிஸ்டன்ஸுக்கு எடுத்து வைக்கிறோம் அப்படின்னும் போது, புஷ் பண்றோம்னு சொல்லும் போது அங்க frictional force act ஆகுது அந்த blockல. So how many forces are acting? One is normal force, another is gravitational force, and Fs is the frictional force. This block is acting horizontally act ஆகுது, not upwards. நான் upward எடுக்கல, I'm just pushing to the earth's horizontal field. அந்த டேபிள் மேலேயே நான் புஷ் பண்றேன், அப்போ frictional force is acting and normal force is acting, also the gravitational force is acting. அப்போ earthோட gravitational fieldலயே புஷ் பண்றேன்னா I have taken it as a cos component. If I pushed the block towards the upper end means I have taken the sin component. Horizontal wise எடுக்கும் போது நான் cos component எடுப்பேன், vertical சொல்லும் போது sin component எடுப்பேன். இப்போ இந்த block நான் horizontal wise தான் push பண்றேன், so I am taking it as cos component. So the normal push of the object depends on frictional. புஷ் அப்படின்னு சொல்லும் போது without friction nothing will happen. So frictional force is equal to, frictional force எப்படி இருக்கு அப்படின்னா மேக்ஸிமமா இருக்கு, which is equal to mu s into n push. How it defines? So the frictional force is maximum, can able to change the object from one point to another point, which is equal to, எதை டிபெண்ட் பண்ணிருக்கு அப்படின்னா the static friction of the block and the normal force exerted on it. Mu means, this is mu s is defined as static friction, and n is the normal force, where mg is the gravitational force, f is the total force, where mu s is the static friction which is acting on the box, n is the normal push towards the box, and mg is the gravitational force, f is the total force. So this f is considered to be an total force, where fs maximum is equal to mu s. What is mean by n push? N push is equal to mg plus f. So open the bracket, mu s is the static friction. For n we are going to substitute the value, that is mg plus f cos theta. The frictional force maximum is equal to the static friction of the n push, static friction of n push. So n depends on mg plus f. So n push க்கு பதில் நான் என்ன எழுதியிருக்கேன், அதோட வேல்யூ mg plus f cos theta. Consider this is equation 1. This is the pushing of an object which experiences a force on the block which is placed on the table. I'm repeating this once again. N push is equal to, normal force is equal to gravitational force the total force, where frictional force is maximum, which depends on the static friction into the normal force. The static friction into normal force, we have the value mg plus F cos theta. So considering this as first. Considering the second case, that is pulling an object. By pulling the block, two forces are acting. One is acting in the upward direction, another is acting in the horizontal direction. By using this free body diagram, upward arrow marks always indicates as normal force. This is considered as normal force, and this is considered as gravitational force. Gravitational force is always acting on the downward direction. If we throw a ball, it comes down. That represents as gravitational force. That is one of the example of gravitational force. And while pulling an object, some frictional force is acting, that is Fs, and the total force acting on the object is considered to be F. So total force is equal to F. Again, we are using the same representation, N push. Instead of N push, we are going to write N pull, which is equal to mg. Mg is the gravitational force. I am pulling, not pushing the object, I am pulling. So mg minus F cos theta. I am representing here, it has the plus sign. We are adding. Adding means we are can able to supplement some of the force, that is mg, that is the gravitational force, plus the pushing an object. If you are considering it as the total force plus the component. Pulling an object means taking away from there. So we are considering it as the negative component. N pull is equal to mg minus F cos theta. If we are pulling something means some frictional force is acting. So Fs is considered to be the frictional force, which is equal to mu s into N pull. So Fs maximum is equal to mu s. What is the value of N pull? Mg minus F cos theta. Assuming this as second equation. Here mg plus cos theta, here mg minus cos theta. If you are pushing an object means some external force is required. Pulling an object means we are taking away from that some external force is less on. So mg minus F cos theta. While comparing to those equations, pushing is easy than pulling.